Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over section 13.4 of our virtual algebra 2 text on log and exponents. We're going to be looking at how to simplify or evaluate logarithmic expressions. The type of problem that we'll be covering in this presentation is presented here. Simplify the log expression, log base 2 of 1 over 8. We're going to be using the inverse property of logarithm, log base b of b to the x equals x, to solve these problems. If this is what you're looking for, don't forget to support this channel by hitting the like and the subscribe buttons. To gain access to the entire Algebra 1, 2, Geometry Pre-Calc and Calc courses, take a look at the links in the description below or visit our website at mathgotserved.com. We're going to be taking a look at the property of logs that will be guiding our problem solving process. The property is the inverse property of logarithm, okay? So we have our ultimate properties of log formula sheet on our website at mathgotserved.com, either in pre-calc or algebra 2 under the logarithms section. So if we scroll down to property number 5 in our ultimate properties of logarithms, there are a total of about 10 here. You can see the property that we're going to be using for this presentation. All right, we have it in terms of log base b and log base e, the natural log. Okay, so let's go ahead and write down these two inverse properties of logarithms that will be guiding our problem solving process. All right, so let's write down the formulas. So the formulas that we're going to be using, these are the inverse properties of logarithms. So the first one is log base b of b to the x is equal to x, and then the second one has to do with natural log. The natural logarithm of e to the x is just x. Okay, so the game we're going to be playing here is trying to express the argument, the log argument, as a power as an exponent with the base equal to the base of the logs, so that we can have cancellation action happening, and then we're left with the value of the exponent. Okay. All right, let's take a look at the first question. So instructions are for us to simplify the following. Simplify the following. All right, so the first one, let's say we have to simplify log base 4 of 64. All right, so to do that, all we're going to have to do is try and express 64 as a power of 4. So just go through your powers of 4. Well, it's 4 to the first power, 4 to the second power, and on and on and on. And then you can figure it out that way. Okay, so 4, let's start from 0. 4 to the 0 is 1. 4 to the 1 is 4. 4 squared is 16. 4 to the third power, just multiplying by 4 repeatedly, is 64. Voila, that's what we want right there. Okay, so we're going to rewrite this as log base 4, and then instead of 64, we'll replace that with the equivalent term, that's a power of 4, which is 4 to the third. Now we can now apply the inverse property of logs, because the base of our log and exponents and the logarithmic argument, which is an exponential form, are both identical. So we can cancel that out, and we are left with 3. And that's the final answer. Okay, let's take a look at another example. Number 2. Let's say we're to simplify the log expression, log base 2 of 1 over 8. Okay, so same procedure. We're just going to try and express the logarithmic argument as a power of 2, which is the base, and then we can use the inverse property of logarithms to simplify it. Okay? All right, so first of all, we have 8 in the denominator. All right, we cannot have a fractional component when our base is an integer, so we have to rectify that problem. So to fix that, we're going to reciprocate. Okay, so when you reciprocate 1 over 8, it becomes 8 to the what? -1. So when you reciprocate, you negate the exponent. Okay. All right, so 8 to the negative 1. Now, let's express 8 as a power of 2. So we have 2 to the 0 is 1. 2 to the 1 is 2. 2 to the second power is 4. 2 to the third power is 8. Bam, there you go. So that's what we want right there. So we're going to replace 8 with the equivalent form as a power of 2. So this is going to become log base 2. Instead of 8, we have 2 to the third power. But hold on, the exponent was negative before, so we just multiply this negative 1 by the 3, so it's negative 3. Alrighty, now we can apply the inverse property of logarithms. These two cancel out, and get our final answer, which is negative 3. Alright, let's move on to question number 3. So for question 3, let's say we have the following. We have a common log. We went over this in the previous presentation. So common log of 1,000. All right, let's simplify that. So we have the common log of 1,000. So we have to write 1,000 as a power of what? We don't know what the base is, so what's our reference? If you have a common log, you do have a base. It's invisible base, which is 10. Okay? If you have a common log log without the base is 10. If you have ln, the base is e, the natural number e. Okay? All right, so we're going to express 10,000 as a power of 10. Let's go ahead and work that out. 10 to the 0 is 1. 10 square, 10 to the first power is 10. 10 square is 10 times 10, which is 100. 10 to the third is 100 times 10, which is 1,000. That's exactly what we want. So we're going to rewrite this as log base 10. Replace the logarithmic arguments with the power of 10 equivalent, which is 10 to the third power. Now that the logarithmic argument in exponential form has the same base as the logarithmic, as the base of your log, then we can apply the inverse property of logarithms and cancel those two out, and we get our final answer, which is 3. Okay, let's move on to question number 4. So for question number 4, we're going to be doing a problem involving the natural log. Okay, so let's say we have to simplify the natural log of e squared. So how do we do that one? Okay, so natural log of e squared. Our logarithmic argument e squared is already in exponential form, base e. So we need to make sure that the base of the exponent, the base of the exponent, the logarithmic argument in exponential form matches the base of your logarithms. Okay. We do not have a base here, so how are we going to determine if it matches the base? For common log, if there isn't any base specified, the default base is 10. How about natural log? For natural log, if you do not have any base specified, well, bases are not specified for natural or common anyway. So for natural log, the base is e. All right, ln is the same thing as log base e. So just imagine as though there's an invisible e right here. All right. So guess what? The base of this exponent, the logarithmic argument of the natural log function, is the same as the base of your logarithm. So we can automatically apply the inverse property of logarithms here. These two are gone, and you have your final answer, which is 2. Bam. It looked difficult, but it's much easier than it looks. Alrighty, let's take a look at question number 5. So for question 5, let's say we're looking for log base root 3 of 1/9. Okay, so let's do this. This one looks a little bit strange. We're just gonna follow the same procedure and then we should be good to go. Okay. All right. So in order to simplify this, still playing exactly the same game. We just want to make sure that the base of the logarithm is equal to the base of the logarithmic arguments written in exponential form. All right. So the question now is, can we write, or how can we write the logarithmic argument 1 over 9 as a power of root 3? All right, so let's do that. First of all, we have a fractional situation here. The base of the log is not a fraction, but the argument is a fraction. So let's fix that by reciprocating. So log base root 3 is equal to 9 to the negative 1 power. Alrighty. Okay, so let's use our powers of root 3 to determine what how we can write 9 as a power of root 3. Okay, so root 3 raised to the 0th power is 1. Root 3 raised to the first power is just root 3. Root 3 raised to the second power is root 3 times root 3, which is 3. Root 3 raised to the third power is, just multiply this by root 3, which is 3 root 3. And then root 3 raised to the fourth power is the same thing as root 3 raised to the second power is the second power, or 3 raised to the second power. Or you can multiply 3 root 3 by root 3 and you will end up with 9. Bam, jackpot. This is the one that we want right here. Okay. Okay, so we're going to insert that. We have log base root 3. And then instead of 9, replace it with the exponential equivalent base root 3, which is root 3 raised to the fourth power. Now that the base of our logarithm and our logarithmic argument in exponential form match, we can apply the inverse property of logarithms, cancel that out, and our answer is 4. All right, let's take a look at another example, question number 6. Let's say we want to find the natural logarithm of 1. What on earth is this? So natural logarithm of 1, we talked about this earlier. For your natural log, you have an invisible base of e. So the question is, can we write 1 as a power of e? Let's do it. So let's try it out. E to the 0th power is, oh, there you go, right there. First step. So we rewrite this as the natural log base e of e to the 0th power, because e to the 0th power is the same thing as 1, right? Now we can apply the inverse property of logarithms since we have a match between the bases of the log and the exponent. So this cancel out, and the answer of this logarithmic expression is just 0. Okay, let's take a look at number 7.
This is the top result.
For number 7, let's say we want to find log base 4 of negative 64. Let's go ahead and try that out. So what is log base 4 of negative 64? All right, so you'll be thinking, okay, you know what, let's go ahead and start writing our powers of 4. Let's do that. So we have, we've done this before, but let's just do it again. 4 to the 0 is 1. 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. But hold on, wait a minute. We have a problem here, ladies and gentlemen. You cannot take the logarithm of a negative number. There are restrictions in the domain of the logarithms. Okay? So anytime you want to take the log of a negative number, it's impossible to do. So this is undefined. It's undefined because the input violates the domain constraints of the logarithmic function. You cannot take the log of negative numbers. Only positive numbers. Okay. All right. So number 7. I didn't even write the number. Number 7 is undefined. Moving along, let's take a look at question number 8. Question number 8, we want to find the natural log of 1 over e root e. There's another strange looking one. So let's see how we can do this. So natural log of 1 over e root e. Following the same procedure, we know what the base is here. Since it's a natural log, the implied base is e. So we just have to write e root e as a power of e, and we are good to go. So first things first, we need to reciprocate so that this denominator ends up upstairs. So we're going to have e root e raised to the negative 1 power. Okay? So let's use the property of exponents to simplify this. So this is e to the first power, and this is root e. So we can combine these two. E to the root e is the same thing as e to the 1/2. All right. Raised to the negative 1. Now we can apply the product property of exponents to combine these two. So we have the natural log. Oh, I don't need, well, I'll just put it e there just for formality, of e to the 1 plus 1/2. Okay? 1 is 2 over 2. Let's not forget our negative 1 here. 1 is 2 over 2, so 2 over 2 plus 3 over 2. 2 over 2 plus 1 over 2 is 3 over 2. So this is a natural logarithm of e raised to the 3 over 2. And they have a negative 1 out there. Okay? Now what we're going to do is just distribute this power to this 3 over 2. So we're going to have the natural logarithm of e. Scroll down a little bit. Natural logarithm is log base e. The reason why I'm keeping that little e there is because so you can see the cancellation action happening. Normally you don't put it there, okay? So let's just put it there just for kicks. So it's going to be e raised to the negative 3 over 2. Bam. This is perfect. Why? Because the base of the logarithm, which is e, natural log, and the base of our logarithmic arguments in exponential form base e are identical. So these two cancel each other out. And our answer is negative 3 over 2. All right, let's try another example, question number 9. Let's say we are to simplify log base 1/2 of 32. We're going to follow exactly the same procedure. So the goal here is to express 32 as a power of 1/2. Alrighty? Okay, so let's do it. So first of all, you notice there's a 1 here, so we're going to apply that here. We're going to write this as 32 over 1. So we're going to reciprocate. Okay, so when we reciprocate this, log base 1/2, it's going to be 1 over 32 raised to the negative 1 power. When you reciprocate, you negate the exponent. Okay, so now can we write 2 as a power of, can we write 32 as a power of 2? Well, let's work it out right here. 2 to the 0 is 1, 2 to the 1 is 2, 2 square is 4, 2 to the 3rd is 8, 2 to the 4th, just keep multiplying by 2, right? 2 to the 5th is jackpot. That's exactly what we want. All right, so we're going to write this as log base 1/2 of the denominator 2 to the 5th. And then we can also write 1 as 1 to the 5th, right? It doesn't really matter. 1 to the 5th is the same thing as 1. The reason I'm doing that is because I'm going to factor out the powers, okay? So we're using the reversal of the quotient of powers property to solve this. All right. Okay. So what we're going to do is factor out these two powers from 1/2, and this is going to become log base 1/2 of 1/2 raised to the 5th power, but there was a minus here, so it's -5. Bam. You see that? All right, and then this is exactly what we want. Why? Well, because the base of the log and the base of the logarithmic argument written in exponential form, base 1/2, are identical, so we can apply the cancellation action. Goodbye, and then we have our answer, which is -5. Let's box that. All right, let's take a look at one last problem. So question number 10. What if you're to evaluate log base 2/5 of 25/4? All right, so let's go ahead and do this. We're going to follow exactly the same procedure that we've been doing all along. Try to make the base of the logarithm match the exponential, the logarithmic argument written in exponential form. Okay? All right, so this is a puzzle. Can we write 25/4 as a power of 2/5? Is that possible? Well, let's express them as powers first. So if you do that, 25 is 5 to the 2nd power, and 4 is 2 to the 2nd power. Now, we can use the reversal of the quotient of powers property. The reversal of power of a quotient property of exponents to factor out these two powers. So this is the same thing as log base 2/5 of 5/2 square. It's exactly the same thing. Okay, we have another ultimate collection of exponential properties at mathgotserved.com on the same page I showed you, so you can review those too. All right, so can we cancel out here? No way. The base of our logarithm doesn't match the base of our logarithmic argument written in exponential form. Can we rectify this problem with one step? Yes, we can apply the reciprocal property of exponents. When we reciprocate the logarithmic argument into 2/5, that results in the negation of the power. This is perfection right here, because the base of the logarithm and the exponents are identical. So we can apply the inverse property of logarithms, those who cancel each other out. And we have our final answer, which is -2. That's the answer to question number 10. All right, now it's your turn for some practice. We have 10 practice problems that we'd like you to try out. So go ahead and pause this video presentation at this time and simplify the following. When you're done, reinitiate the playback process, and we will display what the correct answers are to you. Okay, so go ahead and pause the video at this time and start these practice problems. Welcome back. Hopefully you had a chance to try out the practice problems. Here are the solutions to questions number 1 to 10. Go ahead and check your work. So how well did you do? Let us know in the comment section below what your score was out of 10. And if there are any questions that you have about any of these practice problems or what we went over in the presentation, just specify it in the comment section below and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of logarithms, do give us a thumbs up or like to support, and also share and subscribe. Don't forget we have tons of support resources mathgotserved.com and also in the links in the description below. Thanks again for watching and have a wonderful day. Goodbye.